Question 16c. Kara deposits an amount of $300,000 into an account which pays compound interest of 4% per annum added to the account at the end of each year. Immediately after the interest is added, Kara makes a withdrawal for expenses for the coming year. The first withdrawal is P dollars. Each subsequent withdrawal is 5% greater than the previous one. Let AN dollars be the amount in the account after the nth withdrawal. Part 1. Show that A2 is equal to 300,000 multiplied by 1.04 to the power of 2 minus P multiplied by 1.04 plus 1.05. Let Q equal 300,000, R equal 1.04 and T equal 1.05. Q represents the deposit amount, R represents the increase due to compound interest, and T represents the increase of the withdrawal amount each year. Now A0 equals Q, which represents the amount in the account at the beginning. A1 is equal to QR minus P, so that's the deposit amount, multiplied by 1.04 minus 1 withdrawal of P dollars. A2 represents the amount in the account after the second year, so that's equal to the amount in the account after the first year, multiplied by R, so increased by 4%, minus the withdrawal amount of P dollars which has been increased by 5%. So that's A1R minus PT. Now A1 is equal to QR minus P. So A2 is equal to QR minus P multiplied by R minus PT. Expanding the brackets, we get A2 is equal to QR squared minus PR minus PT. Factorising out negative P, A2 is equal to QR squared minus P times R plus T, and substituting in the values for Q, R, and T, we get A2 is equal to 300,000 multiplied by 1.04 squared minus P times 1.04 plus 1.05 as required. Part 2. Show that A3 is equal to 300,000 times 1.04 cubed minus P times 1.04 squared plus 1.04 times 1.05 plus 1.05 squared. Following on from part 1, A3, the amount in the account at the end of the third year, is equal to A2 times R minus PT squared. Now the initial withdrawal amount, that's the amount withdrawn at the end of the first year, is P dollars. At the end of the second year, P dollars is increased by T, or 1.05. At the end of the third year, it's increased by 1.05 again. Hence why it's minus PT squared. Now from part 1, A2 is equal to QR squared minus PR minus PT. So A3 is equal to QR squared minus PR minus PT times R minus PT squared. Expanding the brackets, we get A3 is equal to QR cubed minus PR squared minus PTR minus PT squared. Factorising out negative P, we get A3 is equal to QR cubed minus P multiplied by R squared plus RT plus T squared. And then substituting in the values for Q, R and T, we get A3 is equal to 300,000 multiplied by 1.04 cubed minus P times 1.04 squared plus 1.04 times 1.05 plus 1.05 squared as required. Part 3. Show that there will be money in the account when 105 over 104 to the power of n is less than 1 plus 3000 over p. The following are the marking guidelines for question 16c, part 3. For 1 mark, we have obtains an expression for AN, or equivalent merit. For 2 marks, we have sums the series for AN, or equivalent merit. And for 3 marks, we have provides correct solution. We need to come up with a general expression for AN, which represents the amount in the account after the nth withdrawal. Following the pattern from part 2, that is, A3 is equal to QR cubed minus P times R squared plus RT plus T squared, where Q is equal to 300,000, R is equal to 1.04, and T is equal to 1.05. From this, we can generalize that an is equal to qr to the power of n minus p times r to the power of n minus 1 plus r to the power of n minus 2 times t plus dot 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 plus r times t to the power of n minus 2 plus t to the power of n minus 1. Now the second term on the right hand side is the sum of a geometric progression with first term r to the power of n minus 1, common ratio t over r, and n terms. So to go from one term to the next in this geometric progression, if we multiply by t and divide by r, we get to the next term along. Now replacing this geometric progression with the formula for the sum of a geometric progression, noting the value of the first term and the common ratio, we get an is equal to qr to the power of n minus p times r to the power of n minus 1 multiplied by 1 minus t over r to the power of n, all over 1 minus t over r. Taking out the r to the power of n minus 1 outside the outer brackets here, we get an is equal to qr to the power of n minus pr to the power of n minus 1 times 1 minus t over r to the power of n over 1 minus t over r. Now money is in the account when qr to the power of n is greater than pr to the power of n minus 1 times 1 minus t over r to the power of n over 1 minus t over r. Now we want to make t over r to the power of n the subject of this inequality. So we want that on the left hand side and everything else on the right hand side. So cleaning up this inequality, trying to simplify it, of course, in the best way we can divide both sides by pr to the power of n minus 1. Now this is a positive quantity. We don't have to reverse the inequality. So we have qr over p is greater than t over r to the power of n minus 1 over t over r minus 1. Notice that the terms in the numerator have been reversed and the terms in the denominator have been reversed. So multiplying top and bottom by -1 doesn't change the value of the fraction. So again, no need to change the direction of the inequality sign. And then multiplying both sides of this inequality by t over r minus 1. Now note that t is greater than r, so the denominator is positive. We get qr over p outside of t over r minus 1 plus 1 is greater than t over r to the power of n. So expanding the brackets and just combining these two terms into a single fraction, we get qr over p times t minus r over r plus 1 is greater than t over r to the power of n. And this r here cancels with this r here. And because we have values for t and r, of course, we can substitute those values back in or evaluate t minus r, which is going to be 0.01. And we can replace q with 300,000. So we end up with 300,000 over p multiplied by 0.01 plus 1 is greater than 1.05 over 1.04 to the power of n. Now 300,000 multiplied by 0.01 is just 3,000. So we end up with 3,000 over p plus 1 is greater than 1.05 over 1.04 to the power of n. And note that 1.05 over 1.04 is equal to 105 over 104. Again, it doesn't change the value of the fraction. So we have 3,000 over p plus 1 is greater than 105 over 104 to the power of n. And that can be written as 105 over 104 to the power of n is less than 3,000 over p plus 1 as required. The following is the feedback from the Marking Centre for question 16c. Skills addressed include having a clear understanding of the steps required to show a result, presenting all work using clear sequential steps, providing a detailed progression from A1 through to A2, responding to the direction show that and providing a detailed progression from A2 to A3, being able to achieve an expression for AN, using the sum of a geometric progression formula to arrive at the given result, and demonstrating a high degree of accuracy and skill in algebraic manipulation. Areas for students to improve include using brackets correctly, Remembering to increase and subtract the withdrawal, that is, using A2 equals A1 times 1.04 minus P times 1.05, knowing that the third withdrawal was P times 1.05 squared, and using A3 equals A2 times 1.04 minus P times 1.05 squared, using patterns to obtain an expression for AN, and using the correct values for the first term and common ratio when finding the sum of the geometric progression.